In this video, we will be analyzing the rational function f of x is equal to 6 over x squared minus 5x minus 6. The first thing we want to do is go ahead and factor this function, and I notice that x squared minus 5x minus 6 can be factored. Remember, we are looking for two numbers that will multiply to give us negative 6, because negative 6 times that 1 is negative 6, and that will add to give us negative 5. So you may think, well, one of them's got to be positive and one of them's got to be negative. So you may try negative 3 and 2, which does give you negative 6, but when you add those together, you get negative 1. Don't forget, though, that there are 1 and 6 that are factors of 6, and if I make that 6 negative, then negative 6 plus 1 would give me negative 5. And since the coefficient of my x squared term is 1, I can go right to the parentheses. So the factored form of my function becomes 6 over x minus 6 times x plus 1. So if I do a quick check, negative 6 times 1 gives me negative 6. X times x gives me x squared. Inside times inside is negative 6x. Outside times outside is 1x. And negative 6x plus 1x gives me the negative 5x. All right, so now I'm ready to look at the domain. Remember, to find the domain, you set the denominator not equal to 0. So I have x minus 6 times x plus 1 does not equal 0. So x minus 6 cannot equal 0. So x cannot equal 6. X plus 1 cannot equal 0. So x cannot equal negative 1. So to write that in interval notation, I'm going to have from negative infinity up to negative 1, union negative 1 to 6, union 6 to infinity. Now I'm ready to find x and y intercepts. Remember, to find the x-intercept, you let y equal 0. And with a rational function, you can just set the numerator equal to 0, because a rational function is 0 when the top is 0. But this one's weird because the top doesn't have an x in it. So 6 will never equal 0. So what that means is there are no x-intercepts. To find the y-intercepts, you let x equal 0, which means I'm going to find f of 0. And I think it's easier to do that up here because anything that has an x in it will go away. So I'd be left with 6 over negative 6 or just negative 1. So I have 1 point so far on this graph, and that would be the point 0, negative 1. All right, so now I'll look to see if there are any holes. Remember, holes occur when there are common factors in the top and the bottom. Since the top does not have x minus 6, it's just 6. These are not common factors. So there are no common factors, so there are no holes. All right, vertical asymptotes. Remember that vertical asymptotes and the domain, and really the holes, go hand in hand. So if you have values of x for where the function is undefined, then there is either going to be a hole there or a vertical asymptote. And since there are no holes, that means we have two vertical asymptotes, 1 at x equals 6, and 1 at x equals negative 1. All right. Finally, the horizontal or slant asymptotes. Remember to figure that out. We're going to look at, let me write this. Look at domain for this. And for this, we're going to look at the degrees. To figure out, is the function top heavy, bottom heavy, or the same? Well, the degree on the top for this function is actually 0. If there's no x value, we can think of it as x to the 0 power, because anything to the 0 power is 1. And the degree on the bottom is x to the second, so that would be 2. So this one is actually bottom heavy. The degree on the bottom is bigger than the degree on the top. And when it's bottom heavy, it's an automatic y equals 0. So I remember this by, if it's bottom heavy, it's going to pull me down, and I'm going to sit on the x-axis. All right, so my horizontal asymptote is y equals 0. All right, so let's plot what we have so far. We have two vertical asymptotes, one at x equals negative 1. Whoops, I meant to switch to red there, sorry. We have one at 6. 1, 2, 3, 4, 5, 6. And we have a horizontal asymptote at y equals 0. Now, I don't think I stressed this in class last week, but I really would like for you to label your asymptotes so that I know that you know what you're graphing. So this is a vertical asymptote at x equals negative 1 and a vertical asymptote at x equals 6. All right, I have a singular point, and that is 0, negative 1. And I'm going to switch to blue now because I'm actually graphing points on the function. All right, so now remember, I'm going to want at least 2 points in each section of the graph. And what I mean by that is your vertical asymptotes divide your graph into different sections. So there's a section over here to the left of that vertical asymptote. There's a section in the middle, and there's a section to the right. Now, I know that there are no x-intercepts, so I know that in this section, it's never going to cross this horizontal asymptote. So I'm thinking it's probably going to come down here. But let me pick an x value over here to kind of let me know what's going on in here. Now, I've picked a lot of different x values, but I need a minimum of 2 on the test. So let's see. I used 3. Let's see, I have a 2 and a 3 and a 5. And I actually even plugged in 5.5. All those are in here. So when I plug 2 into this function, and you can plug it in either one, whichever one's the easiest, I get negative 1/2. When I plugged 3, I also got negative 1/2. When I plugged 5, I got negative 1. And when I plugged 5.5, I got negative 1.8. So if I graph those, let's see, 2, negative 1/2, 3, negative 1/2, 5, negative 1, 5.5, negative 1.8. So I can see it looks like the graph is doing this and coming down and doing this and coming down. So now I need to pick some points to the left of -1. So I used -1.5, -2, and -4. So when x is -1.5, y is 1.6. When x is -2, y is 0.75. And when x was -4, I got 0.2. So let's see, -1.5 was 1.6. -2 is 0.75. And -4 was 0.2. So it looks like the graph is doing this over here. This is right in line with what we talked about on the pink page. So remember that this can tell you what's going on opposite sides of your vertical asymptotes. So if you have a factor that the multiplicity is odd, they're going to go in opposite directions. So if I look, sorry, I'm making you dizzy, but if I go back to example 4, x plus 1 was only a factor once, so the multiplicity is 1. So that means if it's going down over here, it's going to go up over there. Same thing with x plus 6, so I can imagine that I'm going to have a section over here very similar to this graph. But let me give you some values just to show you that. So let's see, I used 6.5 and I got 1.6. I used 7 and I got 0.75. And I used 8 and I got 1/3, which would be 0.3 approximately. All right, so 6.5, 1.6. Sorry. And then 7 was 0.75, and then 8 is 1/3. So it does look like the graph is doing this in this section. And that's the graph of the function. And remember, to get these values, you're going to plug the x values into the function to determine your y values. You can do this in your calculator. You just have to be careful that you put the numerator and the denominator in parentheses so that the calculator knows where the numerator starts and stops and where the denominator starts and stops. So just to give you a quick example, when I was plugging in, let's say 6.5, I had 6 over, and technically you wouldn't have to put this numerator in parentheses because it's a single number, but it's a good idea to get in the habit of that. And then I would start with the parentheses, and then I would have 6.5 squared minus 5 times 6.5 minus 6. Let me extend this. And then remember, you want to enclose the bottom in parentheses as well. So use parentheses for numerator and denominator. Otherwise, your calculator doesn't know where your numerator and denominator start and stop.